Hi, my name is Bernie Wu. I'm the president of Profit Store Data Services. I'm pleased to be here at the OpenStack Summit in Paris. And what I'd like to do today is give you a quick overview of who Profit Store Data Services is and a little bit about our solutions for the OpenStack community. First of all, let me introduce our company. Our company is all about software-defined data storage services. Our flagship product is called Federator. It's been designed for both OpenStack and for enterprise environments. We also have an optional storage hypervisor, which includes a Cinder volume driver, which we certified as of the Juno release. Our focus is on addressing the next generation data storage services for the cloud. In this area, there are three specific things we're working on. First is to increase application and data-aware storage provisioning and provide further automation. Secondly, to provide adaptive heterogeneous storage tiering to optimize costs. And third, provide analytics and use those analytics to further automate and optimize performance. Our company was founded in 2012 in Taiwan. In 2013, we moved our corporate headquarters to Silicon Valley, California. And also we have ISV relationships here within the OpenStack community, including Mirantis, Red Hat, and Ubuntu. Now I'd like to describe our Federated Platform, which is a control plane data services platform. In the middle of this diagram, I'm showing our Federated Platform with connectivity via what we call a storage dock, control path connectivity to third-party storage below us at the bottom of the diagram. Within the platform itself, we have built a policy engine, scheduler, and database, as well as 5 different categories of data services. The first data services are to provide insight, and this includes traffic, analytics, and prediction. The second one is provisioning. Here, what we're doing is providing application-aware elastic storage provisioning. The third one is protection. What we're doing there is providing services around snapshot and replication to speed up recovery time and recovery point objectives. The fourth is recovery and use. Here, what we're trying to do is automate both disaster recovery and test use cases. And fifth is optimization. In this area, we're working on providing migration services as well as performance acceleration. Above us is either the OpenStack or enterprise management plane, control planes, or applications. And we communicate with those via REST APIs. On the side of this diagram, I'm showing the data path. So we are strictly a control path type of orchestration platform. Now I'd like to turn to specifically a use case we're excited about, which is traffic modeling and prediction. As you might expect, in the cloud as well as on our freeways, there are periods of time when there's tremendous congestion due to either application workloads or to large numbers of cars, in this example here. In some cases, this can cause severe performance degradation. In other cases, it causes severe underutilization or overutilization of resources. More specifically, what I'm showing here in this chart is the I/O traffic pattern for a VDI workload over a 24-hour period. The blue graph shows peaks in I/Os per second, basically traffic congestion occurring, as you can see here, at the beginning of the day and at the end of the day, with a dip in the middle during the lunch hour. Above that, the brown line shows the fluctuation in write to read ratios, also during that course of a 24-hour period. So by monitoring and collecting historical information on a workload such as this over a period of time, and then applying Fourier analysis and neural network technology, Profit Store is now able to predict how this traffic might look from a periodic as well as a trending standpoint going forward into the future. So once we do that, we're actually collecting it for 5 different data storage attributes at this point. First is IOPS, second is throughput, third is storage latency, fourth is storage node CPU utilization, and then lastly, capacity consumption. So what do we do with all this information once we've collected it? Well, one of the use cases is to more dynamically control read and write caches going into the storage layer of a cloud. In one sense, we can burst cache to where it's needed based on workload fluctuations during the course of a day or the course of a week. So what we're showing here is once we've created these predictions, we either can communicate via our control path to our own storage hypervisor or integrate with a third party's cache mechanism to allocate storage to meet the workloads. This way we can more efficiently cost-effectively provide storage optimization as well as maintain service levels. Second use case is if we are modeling, for example, a database while it's in dev test, and then we are ready to move it into production. By profiling its traffic behavior and then looking at existing nodes that are already in production and the traffic behavior on those nodes, we can decide either to, we can make better recommendations or actually place that workload in the right storage node for maximum performance. Overall, ProfitStore intends to apply this type of technology across a wide span of application workloads in cloud data centers. And we also intend to use these other 5 data services I described to provide a more agile and automated data services environment. In conclusion, we're excited to be part of the OpenStack community, and we look forward to working with both the community and the end users. Thank you very much. My contact information is there below if you have any questions. Thank you.